Assalamualaikum warahmatullahi wabarakatuh. My name is Irsyad Azharusyarif Yudhiza Putra from Master of S2 SF. Yeah, S2 SF. So today I want to present an algorithm called ant colony optimization algorithm, which is one of the algorithm from the evolutionary algorithm tree. Okay. First, what is ant colony optimization algorithm? So in computer science and operations research, it is a probabilistic technique for solving computational problems that can be reduced to finding good paths through graphs. So it is actually like mimicking how do a colony of ants looking for a food, and how do they looking for a shortest path or the safest or the most optimum way for them to search food. And this algorithm is mimicking that way of ants. How do they look for their purpose? So how to apply this specific algorithm? The optimization problem needs to be converted into the problem of finding the shortest path on a weighted graph. So in the first step, on each iteration, each ant stochastically constructs a solution. For example, like the order in which the edges in the graph should be followed. The second steps, the paths found by the different ants were compared. So it's like these ants are looking back to their previous paths, and see which is actually the best path for them to follow. Third one, or the last steps, consists of updating the pheromone levels on each edge. So this is the pseudocode of the ant colony optimization algorithm meta-heuristic search, actually. One of the evolutionary algorithm. So this code is keep looping or keep running while it's not terminated. It means that it will always loop until a certain condition or certain situation where the loop should be ended. So there are three steps, or three steps, as I mentioned before. The first one is the generate solutions. So ants will explore different possible solutions by following each path or pheromone, we could say, as their heuristic information or their trails. Next one is the daemon actions. So it's like an optional step where additional problem-specific improvements were applied, such as a local search to refine solutions. So that is the second steps that I mentioned before, where this condition or this formula is this comment is referring back to the previous path that they were followed or they were traveled before, which is actually it is a better path or not with the previous one. And then the last one is the pheromone update, which is after the solutions from their way or their paths were evaluated, the algorithm updates the pheromone levels. So it's like leading to, what could I say, leading to better solutions, to retrieve what should I say, stronger pheromone. Yeah. And then after certain iterations, at the maximum amount of iterations, it could end the loop. So next one is the edge selection. The decision process, each ant constructs a solution by selecting edges based on length and pheromone levels. So for examples like moves from state X to Y probabilistically. So yeah, moving from one node to another, considering its attractiveness or the heuristic desirability of the move, or biologically saying that the this ant has a desire to move uh to move from this path, or via this path. And then the trail level, which is the past proficiency of the move. So the trail level is posteriori measure of desirability. So it is it's like how big or how much do they want to travel on that path. And in general, the kth ant moves from state X to Y with probability. This is the probability of the age selection, which contains the variables of pheromone level for transition from state X to Y, and controls the influence of pheromones, attractiveness of transition, where D is the distance, and controls the influence of attractiveness and represent trail and attractiveness for other transitions. This is how the pheromone could be updated by this equation, you could say. Trails are usually updated when all ants have completed their solutions. So, which this is the variable, like pheromone level for transition X to Y, pheromone evaporation coefficient, which is, yeah, this is a coefficient as it could say, number of ants, pheromone deposited by the kth ant, and typically used in TSP, or traveling salesman problem, which we have been discussed about this problem before in the class with graph-based moves. And this is the equation while the nth k, it means that the let's say a number like the 100th ant or 200th ant uses curve xy in its tour. Otherwise, where lk is the cost of the kth ants, back again, typically length, and q is a constant. So applications of this algorithm is must visit each city exactly once. So this is actually the what should I say, the imaging of how do this algorithm works. So it's like, let's say back again to the travelman cells problem. So each city must be visited exactly once. A distant city has less chance of being chosen, which is the visibility itself. The more intense the pheromone trail laid out on age between two cities, the greater the probability that the age will be chosen. So it means that if there is an age between two cities, yeah, I'm just repeating what to the slide says actually, but yeah, let's say there is an age between two cities, an age between two cities. So this age will be more favorable to choose compared to other ages option, because it could say that with a short travel distance, it could reach two cities or more, even if there's any age between more than two cities. And having completed its journey, the ant deposits more pheromones on all edge it traversed if the journey is short. So yeah, they deposit more pheromones. It's like making mark there where this note or this age or this city is could be the best path. And after each iteration, trails of pheromones evaporate. And this is the image processing for age detection. There are a few steps to do this with a lot of equation here. So step one, which is initialization. So randomly placed k ants on the image. It's like two image with randomly how much ants do you want to put in there, where k, yeah, with that equation, pheromone matrix with that variable were initialized with a random value. The major challenge, the initialization process, is determining the heuristic matrix. Next, the construction process. The ant movement is based on 4 connected pixels or even 8 connected pixels. The probability with which the ant moves is given by the probability equation with the variable of p, x, and y. So there will be px and py. Step 3 and 5. I'm not sure how do I why do I write this as a step 3 and 5? I mean, yeah, let's say this next step after that is update the process. The pheromone matrix is updated twice. In the previous step, no, I mean in step 3, the trail of the ant was updated, whereas in step 5, the evaporation rate of the trail is updated, which is given by that equation. So this is the decision process. Once the k ants have moved a fixed distance L for n iteration, the decision whether it is an H or not is based on threshold T on the pheromone matrix. I forgot how to say that variable. I'm so sorry. The result for the below example is calculated based on Otsu's method, which is another topic to discuss. This is an image age detected using ACO and colony optimization algorithm. The images below were generated using different functions given by the equation 1 to 4. So, I'm sorry that I made a conclusion on the other notes here. So it's like the ant colony optimization algorithm. An artificial ant is a simple computational agent that searches for a good solution to give optimization problem. So these ants could, yeah, let's say, biologically think that naturally ants will choose the best way they could, the best way, the best path they could choose to travel for their purpose. It's like looking for food or even just to migrate. Yeah, I guess that's all that I could present, which is I still put too many texts on my slides. I hope that my presentation is, yeah, at least good enough for Mas Agung to what to create. Yeah. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.